Welcome to solverfy.
A reaction between sodium carbonate and potassium permanganate. Specifically, we're titrating a 0.2121 gram sample of our potassium carbonate, sodium carbonate with 43.31 mils of some potassium permanganate solution. We don't know what the molarity or normality of our potassium permanganate is. And the idea is that if we can figure out how many moles of potassium permanganate it would take to react with this many grams of our sodium carbonate, then we could know how many moles of potassium permanganate were in our solution and figure out what the molarity was. Right. So one thing that we'll want to do is to know what the ratio between potassium permanganate and sodium carbonate is in a given reaction. And what I mean by that is we want to look at the reaction provided. Two manganate ions, or permanganate ions, react with 5 carbonate ions, right? As well as 16 protons, to give 2 manganese cations plus 10 molecules of CO2 and 8 molecules of water. Okay, but what we get from this is that in a given reaction, 2 molecules of permanganate are consumed whenever 5 molecules of carbonate are consumed. And what that tells us is that we can figure out how many moles of carbonate we had in our 0.2121 grams. If we divide that number by 5 and multiply it by 2, that'll tell us how many moles of manganate, and specifically potassium permanganate, it took to consume it. Right? So this tells us the ratio between our carbonate and our permanganate. Now, the way we do this mathematically is that we can take our sodium carbonate, and we're going to do unit analysis. We're going to say we had 0.2121 grams of sodium carbonate. Okay, and we can figure out how many moles we had of sodium carbonate by using its molecular weight. Right, we simply multiply the grams by the molecular weight. A molecular weight you can calculate by hand, but for this type of problem, unless they're specifically asking you to, it's usually best to just look it up. In this case, it ends up being about 134 grams per mole. Note, however, that they are asking for 4 sig figs, so we'll want to use at least one more sig fig from the molecular weight. Okay, so we want to put grams on the bottom and moles on top because we're trying to convert from grams to moles. So we're going to say 133.998. Okay, that's grams for every 1 mole, and that's for sodium carbonate. Or we could also think of this as, I guess, sodium oxalate. It's not necessarily, I'll just keep calling it carbonate, but same idea. Okay, so this is the molecular weight, right, which tells us that we now have units of moles of sodium carbonate. Okay, well, we want moles of potassium permanganate, so we're going to use this factor here, right, to convert our moles of sodium carbonate into moles of permanganate, right? And what this factor tells us is that for every 5 moles, 5 mole of sodium carbonate. Right, we have 2 moles of permanganate. Right? So if we track this to our grams, cancel with grams, moles of sodium bicarbonate, or sodium carbonate, cancels with sodium carbonate, and our final unit is moles of manganate. Right, so it's basically a unit analysis problem. Okay, so how many moles of permanganate do we have? Well, we need to put this into our calculator. 0.2121 divided by 133.998 divided by 5 times 2. And I get 0.0006334. Let's round this off at 4. We could also say 6.33144 times 10 to the minus 4 moles, whichever way you'd like. Okay, so we now know how many moles of potassium permanganate we had, or manganate ion, but there's a 1-to-1 relationship between manganate and potassium permanganate, so we can simply divide by the volume of potassium permanganate. Now, one thing is that we've been given this volume in milliliters, right, but normality or molarity is going to be per liter. So we'll set this up as follows. We'll say 6.33144 times 10 to the minus 4 moles. Okay, and that's of our K, M, and O4, potassium permanganate. And then we know that we want to divide this by our volume, which is 43.31 mils. But we know that we want liters in the bottom, not milliliters. Right, so we'll use a conversion factor to convert mils to milliliters. Right, there are 1,000 milliliters per liter. If we look at this, what it would do to our units, we'd lose mils, but we'd have liters in the bottom, so that's exactly what we want. Okay, so now we just need to plug all this into a calculator. We take the number that we had, we divide it by 43.31 and multiply it by 1,000. And we get 0.019007.6. We can just cut it off there. And this is molarity or normality, whichever way you want to call it. Just pick one of these, though. You wouldn't put both molarity and normality. Okay. Now they did want this to exactly 4 significant figures, so we need to cut it off here, which means the 7 will round up. So our final answer would be more like 0.01901 moles per liter, or molarity, or normality.